Hello, 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 everybody. It is Thursday, the 30th of July. Welcome back. And today, we're going to be doing some of the sort of final weird stretch exams for ESAT preparation for the physics. Apologies for the sort of like last minute notice of this stream. I know, like, ideally, it would be really good if I had like a really solid regular slot, but for some reason, guys, this summer, this July has been like the busiest July on record for me. Everyone has been wanting sort of lots of sort of summer intensives to sort of redo the predicted grades, a little bit of like TMUA prep, some ESAT prep. And so I've just been much, much busier than anticipated, which is why I'm like, okay, back to the sort of usual, let's just sort of slot it in when I can slot it in. So apologies for that, but thank you very much for those of you who are showing up. As usual, for anyone who is here, you want to drop something in the chat, you can drop something in the chat. We can pivot to what you need. All the usual stuff applies. But my main goal for today is to have a go at the PAT paper. So I've had a go at the Section 2s for the NSAA, which are really good at this early stage to not burn through those Section 1s that you need as you move closer to the real thing. PAT papers are also very good, especially if you're doing the physics side of things. I think from next month, I'm going to cover some of the chemistry and maybe do a bit of the TMUA spec stuff, just to make sure there's resource available for all of that. But actually, while we're here, one thing I do recommend at this stage, because, let's talk about where we've come so far. So we started by talking about the broad overall strategy of doing the push physics and then coming through and doing some speed work as well. So we've also spent a lot of time going through the specification. We spent some time going through the sort of detailed notes for the differentiation and integration and sort of showing you where you can find these detailed notes. So in terms of preparing for the content of the ESAT, we're kind of there. And once you've done that, once you've spent July studying all the material and you kind of look at the topics on the list and think, you know what, I can do this, that's the point at which you should do your first full run of an ESAT paper. So that's what I'm recommending for my students now. Doing one full timed run diagnostic test to see where you're at. Is your confidence level where it should be? Are you making, is there a topic where you're like, oh, I think I was fine in that, and then you see a question in it and it doesn't quite work? Now is the time, while you still have August to dedicate to it, to find out where you need to put that effort in. So doing one clean run now will advise you on where further studying you need to do, any adjustments you need to make to your exam technique, and it's a really good use of that, as opposed to saving all of them to the last minute, because as soon as September hits, that's when you're doing all the new school work, you're doing your personal statement work, you're doing your UCAS preparation, and so you don't have as much time to dedicate to the ESAT. So now is a good time, as we change months, start of August, get a run done, find out where your strengths and weaknesses are, and then so that can sort of direct your targeted practice as we move through. Actually, before we launch into the ESAT, I want to show you guys something that I've been doing with some of my students this week from, actually, of all places, ChatGPT. I know I hate tech, but I've relented to using a generative AI, mainly because I had a friend who wanted to use Claude, but then it was going to make me sign up, but I went, no, you get none of my information. So let me show you. It's specifically when it comes to that speed training. So, right, let's get some. Okay, so I'm an ESAT student, a student preparing for ESAT. And I need to work on my speed. This is what I recommend, something like this. Can you give me 5 questions to do in 2 minutes where I have to multiply 2 decimals, something like that. And then it comes up with some ideas. These are not quite in line with what I was going for. Can they be decimals? Can they have nice tricks to them? So something more like 28 times 0.35, something like that. Oh, sorry. Both should be decimals. Takes a little time to get there. Right. So something like this. Oh, can I annotate on this? Maybe not. Hold on a minute. I'll use the annotate. I know what I can do. I can use my little pen tool. Doop. Right. So something like this. You go and you set a timer. Can you see this? Probably not. Let me zoom in a bit. There we go. So I don't want the spoilers for the tricks, but for instance, this is where you can really practice your factor redistribution. So as I'm going through, I'm looking at this. I see, well, that, oh God, that was way too thick. So that's equal to 1.4 times 7, which is 9.8. So that's that factor redistribution using that. So here, that's 2.4 times 5, which is 1.2 times 10, which is 12. This one here, we can take 4 from that and put it across. So it's 1.6 times 5, which again, 0.8 times 10, which is 8. This one here, that's an eighth of that, which is going to be 0.9. And that's 3/4 of that, which is going to be 3 times 2.1, which is equal to 6.3. So something like this. This is preparing for ESATs. That's a good point. I will introduce you to what the PAT test is. But for now, I want to show you, just because this is what's been coming up in my practice, how you can use short bursts like this to practice things like factor redistribution to make you faster and more efficient at the non-calculator work. So, very good comment question asking me what the PAT test is, which is going to be the main aim of today. So the PAT test was the physics aptitude test that was used mainly for Oxford. So it got you into Oxford for physics and maybe engineering. So it went back to 2006, I believe. And then it's actually now been discontinued and it's been replaced with the ESAT for people going for Oxford for these things. So Cambridge never took it up, but I think it was Oxford specific. So it was the similar level of entrance test for getting into Oxford physics. And it's now been discontinued. And what it means is that because it's not the same as the ESAT, you can have that Oxbridge entry-level physics come at you without burning through relevant papers, right? So if I show you what the PAT is, so here we have it, Colleges of Oxford University, entrance for physics. I'm taking the 2006 because that's the earliest available. You will find that they always have a few multiple choice at the start, which I think is very good practice for general ESAT work. The specification is not exactly the same for PAT as it is for ESAT. So the PAT really likes questions like eclipses, which are not directly relevant. But I think it's still helpful to stretch. The multiple choice is quite appropriate. The long form written questions after that are more of your stretch targets to get you prepared for interview, say, or to just raise your physics level so the ESAT feels easier in comparison. You can find the PAT, if you just search up like PAT tests past papers, you'll find them going all the way back to 2006. So you can just run at these. And they're one that I use a lot if, for instance, you've run out of the NSAA Section 2s. So let me go through this and kind of show you. I'm not going to set this to time because it's more of a sort of stretch paper. But let me go through and you can see the types of question that are available and whether they're sort of appropriate and like how to use them. So for instance, this first one here, that is clearly a Subat equation. Well, that's a speed times the time, so that is a displacement. It's just that easy. And also, actually, annoyingly, calculators may be used in this paper. So I will have a calculator on hand, but I'll try not to use it unless necessary. It has sides of 3, 4, 5. So that means the volume is 0.03 times 0.04 times 0.05. Well, that is, so it's 3 times, so 2060. So it's 60 times 10 to the minus 6, because each of those was times 10 to the minus 2, and there's 3 of them. So that's the volume. So the mass is 8570 times this guy. This I will need to calculate. So 8570 times 60, 10 to the minus 6. It's 0.5142 kilograms. I want to check what they're using for G. They're taking 10. So the weight is 5.142. Nope, can't write. Illiterate. 5.142 newtons is the weight. Maximum pressure is when that weight is being applied to the smallest face. So that's when the 5.142 is being applied to the area of the 3 times the 4. So 0.03 times 0.04. Sorry, I didn't need to use my calculator. Okay, this is actually, I'm going to pause and really explain this. This is super important, right? Because in ESAT, they will sometimes do things like this. And my advice is always, don't bother doing the calculation because things might cancel. So what I should have done, let me rerun this to show you what would have happened for an ESAT paper. And this is why it's good to practice on things where you can burn through them, right? So the mass, so the weight is mg. So it's 8570 times the volume times the 10. And the pressure is that divided by, is that force divided by the smallest possible area, which is the 0.03 times the 0.04, which are going to cancel. So I could have made my life so much easier, guys. And I could take a factor of 2 from there and put it into here. So that's going to be 4,285 times 0.1 times 10, which will both cancel. So that's the pressure, and the answer is A. So that idea, never bother, if it looks like a complicated calculation, chances are it's going to cancel down in an ESAT. And so getting used to just laying it out without doing the calculation and finding ways to simplify it first. Super helpful tip, that. Question 3 here. Diagram shows the approximate orbit of the dwarf planet X around S. Which of the following is false? Well, A is false. D is where it's moving the slowest. It moves the fastest when it is closest to the sun, when all that GP has been converted into kinetic energy. But let me check the others just in case. Same speeds at A and C. Sure, because they're equidistant from the sun. It moves in an ellipse with the sun at one focus. That is true. I believe that is Kepler's first. Potential energy changes during our orbit. That is true. It does change. And D is where it is the biggest, which means it has the least kinetic energy. Good. Okay, now, guys, this is a challenge. This is not very ESAT, but this is so interview. This is so interview. And it really messes with my head, all of this floating stuff. But let me see if I can kind of get there. So a hollow toy boat is floating in a bath. So, okay, what's happening here? My brain really, really hates floating, but the basic idea here is that there is a weight down and there's a force up equal to the volume submerged times the density of the water times G. I think it does stay the same, but doing so rigorously is the difficult thing. So basically what happens here is, what we're doing is we're changing it. So now, so the basic idea here is the full weight is balanced by this volume times the density of the water times G. So what we know, man, again, rigorous. To do so, like, sort of, it seems like it should stay the same. That part's easy, but the rigorous one is really tricky. And I don't think in time they were expecting you to do that. But how would we do that? So the first thing you do is you take out a tablespoon of water. So the water level goes down. You then put it in here. So we know we add more weight, so it moves down a bit. And that's going to make the water level go back up again. It moves down until the volume submerged equals the weight. There's an extra amount weight added, which is the weight of the water of the teaspoon. So we need there to be more upthrust equal to the weight of the water of the teaspoon. Yes, which means a new volume submerged has to be equal to the volume of the teaspoon, and it ends up being the same. Okay, I know that was tricky. Let me try explaining that again, guys. So we move to a situation where we have the W plus the weight of the tablespoon, which is equal to the weight plus the volume of the tablespoon times the density of water times G. So what we need in order to balance that is for this to be the original weight of the water displaced. And we need to add on this thing for it to balance. But you'll notice that thing is just the density of water times G times the new amount of volume displaced. So in other words, yes, 1 tablespoon was removed, but now an extra tablespoon is displaced. So it's almost like been removed from the water, but then put back in by the extra weight downwards. So that ends up being exactly the same. Absolutely let me know in the comments if that did not make sense, and I will redo that. That is my best attempt to try and teach that, but this is one my brain just does not like. It's not very intuitive. Quantum mechanics, this is guaranteed not showing up on the ESAT. This will be for curiosity only. This will be especially true for people, maybe if you've put something like this in your personal statement as an interest, if you have covered it. This is sort of showing how I would walk this through, more for an interview setting. So in quantum mechanics, the de Broglie wavelength, mind you, they're giving it to you straight up. So they've defined it for you, where the de Broglie wavelength is the Planck's constant over the momentum. Protons of charge E and mass m are accelerated from rest through a potential V. Now, okay, this is the part that you haven't covered this part yet, so I should probably really skip this. But remember, potential is work done per unit charge. So the work done would be QV. So in other words, E times V. And that energy is the half m times the speed squared. So mv squared is equal to 2ev. M squared v squared is equal to 2mev, which means that the momentum, which is the square root of that, is root of 2mev. So the wavelength would be h over root 2mev, which is b. No worries if that didn't make as much sense, because it relied on electric fields, which are not part of the ESAT spec, and most of you will not have covered yet in year 12. But 6, you will absolutely have covered. Give myself a bit more space. Actually, I'll just pop to the other side. Whoop. So a car accelerates steadily from 0 to 20 in a distance d and a time t. So let's see about this. Constant acceleration means we're allowed to use SUVAT. So it travels d from 0 to 20 in t. Another car takes a time 2t to accelerate steadily from stationary to the same velocity. Okay. So from 0 to 20 in time 2t, well, we know that s would equal to average speed times time, which is 2t. That would cancel, that would be 20t. But from here, the displacement would be the average speed, which is 10 times time, so d is equal to 10t, so it is just 2d. And I think that's simpler than it looks. So again, this could be a sort of ESAT style question, which you can do quickly, which might trip some people up if they're overcomplicating it. 7, this is a classic PAT style as opposed to an ESAT style. Work with me here. And the business of building custom solar systems, their basic model has 5 planets in circular orbits at distances d such that they are perfect square multipliers for basic length. How are these related? Well, it's clear. Apologies, it's saying message retracted there. So I don't know if you got rid of that comment or if it's sort of auto-moderated. But feel free to let me know if you want to let me know what that was. So here we can quite clearly say that these are these are the cubes and these are the squares. So we know that the square root of the distance is equal to the cube root of y. So d to the 3 over 2 is equal to y. We know that d cubed is equal to y squared. Well, hold on, this first one is c. It's a sort of, I missed a constant of proportionality here. But we can see that y varies with d to the 3 over 2, which is that thing there in c. And we kind of got there from laying out what these things are. So the square root d, you get 1, 2, 3, 4, 5. Cube root y, you get 1, 2, 3, 4, 5, which is how I kind of pieced that together. 8 in some variation feels like a very ESAT question. Attempts to measure his mass using a set of bathroom scales in his house on Mars and gets a reading of 93. The reason why he gets a reading of 93 is because it measures a weight of 93 times 3.8 even. That is a calculator one. So they would give you better numbers in the ESAT, but that's 353.4 newtons is his true weight. Oh, sorry, the scales were designed for use on Venus. Sorry, so in which case, that is his true, no? Hold on a minute. So the scale on Venus is designed to measure the force. So it thinks 93 times the 8.8. So in other words, this is his true weight in newtons. So if his scales were designed for use on Venus, the scales on Venus are designed to feel that weight and divide by the gravitational field strength to give you a mass. So it measures a weight of 818.4, divides it by 8.8, and that gives out the reading of 93. In practice, though, mass is equal to weight over the gravitational field strength. So his true weight is 818.4. In practice, on Mars, he needs to divide that by 3.8. Yes. And he gets a mass of 215.4. So C. So in other words, his 215.4 kilograms of mass are being pulled down with this gravitational field strength, producing a weight of 818.4. And because the scale thinks it's on Venus, it thinks you're supposed to divide by 8.8 to give you a reading of 93 kilograms. Okay. A metal bar is cooled as it contracts. Which of the following is true? It is not true that the mass increases, because that implies you would have to be adding atoms, which does not happen. The density increases and the mass remain constant looks good. The density increases if it contracts. But the density increases, so D is not correct. So that's why the answer is B. You can get questions like this in the ESAT. Hot air balloon is descending with a steady speed. Okay, so this is going to be another SUVAT. I'm going to be weird here, guys. I always like to work in up positive, even though it means I work with a lot more minus signs. So A is minus 10, I think we were using. It starts off at minus 11, actually. So it starts off moving downwards at 11, and then it gets released, and it takes 7 seconds to fall to the ground. Let's work out H. So H equals UT plus a half a t squared. So it will be negative because it moves downwards. So 77 plus 5 times 49 is 322, which is C. Comment. Oh, excellent point. To make answering these easier, would you recommend using approximations and calculations? That is really good, actually. I do really like that idea. Let me see how that would have worked on question 8, for instance. Because you're right, challenging yourself to do things non-calculator is always best. So how would approximation have worked here? Well, first we can say that the weight that that Venus one measures is the 93 it thinks it is times the 8.8 that it thinks it is. So then the actual mass is the weight experienced, but because of the actual gravitational field strength of 8.8. So for instance, what could we do here? We could round that up to 10 and that up to 4, maybe. That's a possibility. We could round that up to 4 and keep that. So hold on, let me try that first. So we approximate this as being 4. That would be 93 times 2.2. Which would be, now I'm going to multiply, take the 2 there and put it here. And that's going to be 186 times 1.1. Let's move the decimal place over, because I like multiplying by 11. Because that would be a 6 at the end. 402, I think. No, did I misdo that? No, I think that is correct. Let me just check my calculation on that was correct. I did get that. So it's the one that's closest to 204.6, which would be C. So approximation, it would work here. And we can go further and say that because we increased the number on the bottom, that means what we have found is an underestimate. So we want something close to this that's slightly above this, which would be C. So you are right. That's a great recommendation to use approximations in these calculations. Okay, so this is normal brightness. Determine whether these are brighter, normal, dimmer, or off. So here, we can see both that the voltage that each of these bulbs experiences is halved, and also the current, the total resistance is doubled, which means that the current is halved. So in either case, there's less power through the bulb. There will be less energy from the bulb. This will be dimmer. B, we have double the number of bulbs, but double the number of cells, which means that the total voltage and total current will be the same as the original, and this will therefore be the same. over here so you can see it a bit better. Right, how am I going to explain this? Okay, so in any closed loop, voltage gained equals voltage lost. So if we take this outside loop, we make exactly the same argument as here and argue that C must be the same. But that means if each of these gives you a voltage V, each of these receives a voltage V, and in any closed loop, voltage gained equals voltage lost, which means if it gains V there and loses V there, there's no voltage left for D. So D must be off entirely. F, well, let me see. That is exactly the same voltage on exactly the same resistance. So I think this would be the same because power equals V squared over R. Whereas here, and this loop here, voltage gained is V. So this would be V over 2. There's less voltage on that, so I think this would be dimmer. Out of curiosity, though, I'm going to play around with this. I want to see what the equivalent resistance would be. So 1 over R equivalent would be 1 over R plus 1 over 2R. So 2 over 2R, so it's 3 over 2R. So the equivalent single resistance would be 2/3 R. The voltage would be the same. I equals V over R. So that would go to 1.5, the initial current. So the current through the cell would definitely increase. But then it's going to split in proportion. So this has more resistance, and therefore it's going to experience less of the current. It's going to be 0.5 of the current, and this would be a single one. So this has exactly the same current moving through it. This one has half the current moving through it and half the voltage. So it's a quarter of the power. So it's dimmer. So you can see these little things that just really test your circuit rules. G and H, I'm still going to use Kirchhoff's second, that in any closed loop, voltage gained is voltage lost. So if that's V, then that's V from this loop here. From this loop here, if that's V, then this is V. So I expect H to be the same. And from the total loop on the outside, let me just make sure the currents are going the right way around, though. Maybe not. No, I think it does work. Because in this one down here, voltage gained is voltage lost. So this has to have double the voltage going the wrong way around. So this would be brighter. G would be brighter. The other way to get there is through Kirchhoff's second around the outside, around the outside, around the outside. It gains 2 volts, both of 2V, both of which have to be distributed on G. So it is brighter than normal. This is such a classic PAT test style question because it's not very helpful for the ESAT. You can skip this. This will be completely fine. But this kind of stuff, very good for interview, very good for that kind of just like coming up with a process to get to the answer on the spot, doing your best, muddling through. So here, exploring the North Pole of Mars, an astronaut stumbles into a cave containing a pool of glowing liquid and a collection of colored cubes. Lacking any proper instruments, she uses her spare oxygen tank as a measure and determines that a red cube and a green cube together are as long as the tank. So the length, these are about lengths. This is about lengths. This is about weight. So I'm going to say that any letters that I give are going to be for the lengths. So the red length and a green length equals the tank length. 2 green lengths and a blue length are twice as long as the tank. A red cube and a blue cube together are as long as 2 green cubes. and they weigh the same as the tank. So the masses, are they all the same density? Find the density of the glowing liquid. I'll get to D later. Hold on a minute. She tries dropping the cubes into the pool and notices that they all float with half of their volume exposed. So all of them. The way this works is when the weight down, which is their density times their volume. So the density of the cube times the volume of the cube is balanced with the density of the liquid times the volume submerged. What we're told, because they float with half their volume exposed, means that half their volume is submerged. So this would be half the volume of the cube, which means that the density of the cube is half the density of the liquid for all three. What that means is they all have the same density as each other, which is half the density of the liquid that we're trying to find. So far, so good. Now, the reason why that matters is if they all have the same density, well, we know that what that mass is. So these masses adding together will give you 20. So whatever the density, so the density times r cubed plus the density times g cubed plus the density times b cubed equals 20. And the tank is 35. I'm going to work in centimeters for now. So if the tank is 35 centimeters long, that's 35, that's 70. So that gives us 4 equations for 4 unknowns. I can use these 3 to solve for R, G, and B. So doing, that's meant to be, oh, that's 2G, apologies. Well, we know that G is equal to 35 minus R. So R plus B is 70 minus 2R. So 3R plus B is equal to 70. Okay. And we know that 3R plus 3G is that times 3, which is 105. So 3G minus B is equal to 35. And apologies, you cannot see what I'm doing. So we've got that relationship. And to reiterate, we also know that 2G plus B is equal to 70. So if we add those together, then 5G equals 105. So G equals 21, which means that 42 plus B is equal to 70, meaning that B is equal to 28. And R plus G is 35, which means that R is equal to 15. Let me make sure this works. So we said that R is equal to 15. We said that G is equal to 21. Methodically, I'm going, by the way. So B is equal to 28. Let me just check that works. These sum to 25. 42 plus that equals 70. R plus B is 43, is not twice G. Is B 27? No, I did something wrong, guys. No! Right, let me try and find it. as long as the tank. 2 green cubes and a blue cube are twice as long as the tank. R and a blue as long as 2 green cubes. So what did I do wrong? So 35, G is 35 minus R. So double that, 70 minus 2R. Add that across, so 3R plus B is that. That is true. And then triple that, you get 105. That is true. So that minus that equals that minus that, which is 35, which is true. 2G plus B equals 70. So add those together. 5G equals 105 is correct. So G equals 21 is correct. Two G plus B equals 70, which means B equals 28 should be correct. And red plus green is 35. Oh, sorry, 35. So that should be red should have been 14. Got it. Apologies, guys. My bad. Simple execution error right there. Great. So that works. So we know what the lengths of the red, the green, and the blue are. And therefore, we can work out the density of the cubes. Because the density of the cubes, well, let's just go straight to liquid. So the density of the liquid is twice the density of the cubes. So it's twice the density of the cube, and we can rearrange this for the density. So it's twice times the density, which is 20 over. Now, this is one where I am going to have to just type it in, not even approximate, because it's just insane. Now, actually, these are in centimeters, so I should make these proper volumes. So in kilograms per meter cubed. Okay, right, let me run that real quick. So it's going to be 40 over 0.14 cubed plus 0.21 cubed plus 0.28 cubed, which is 1778 kilograms per meter cubed. That was insane. Woo! I mean, you just gotta, but the reason why to do this, right, it stretches your ability. None of those steps are actually too difficult, but that's so like interview mindset, just making sure you can calmly go one step to the other, explaining your steps, getting there nicely. Really, really good. So is the velocity of a rocket as a function of time. What happens at point X? Well, we can see I think what happens at X is that the engine shuts off because it starts decelerating with a constant acceleration, which I assume, I mean, it really looks like it's going to be minus 10. So I think it's free falling. So the engine turns off and it free falls. What is the acceleration of the rocket at maximum? When is the acceleration a maximum? Suggest an explanation for this. Well, it seems to be accelerating at an accelerating rate. So it seems to be the biggest at X just before it shuts off. Why would this be? Well, we know that force is rate of change of momentum. F equals ma. If F equals ma, then A is equal to F over M. So let's argue, for instance, if we assume that that driving force is a constant, we know this thing is losing mass because it's burning fuel. So its mass is decreasing, which means for a constant driving force, the acceleration is increasing. That might be the suggested reason. Why? Describe the subsequent motion of the rocket. It just decelerates until it hits the ground. Assuming no air resistance. Otherwise, it might reach terminal velocity. And how, in principle, would you determine from this graph the maximum height reached by the rocket? Maximum height, you would take the area between the curve and the t-axis. Once the v hits 0, that's when it has stopped and is starting to fall back down again. Okay, and then question C, I have done this one before. I think I've done it in an interview prep stream. It's extremely good for interview prep because it gets you to derive expressions. So we can see basically from this, sections B and C are really not as relevant to the ESAT, apart from maybe this stuff here with the circuits. But B and C are more sort of, well, A is, any sort of multiple choice is extremely good for the ESAT. Any short form is sort of an in-between, and any long form question is super interviewee. But here, let's show you how this works. Mathematical treatment. Are you going to go through the math section too? Oh yeah, you know I am. Most certainly. And in fact, I might throw in some math test. No, that would probably be too. Math test question one, we'll see. Math test question one's very good for TMUA, and I might introduce it here just so that you guys see it, in case you really want some math stretching material. So the problem concerns the mathematical treatment of simple model. And by the way, the math I have completely not seen. So this stuff I have at least had the jam jar loosened. So the batteries provide electrical power source with constant power P. Neglect air resistance and other imperfections. So the car is placed on a level surface and the motor is treated as a device which converts electrical energy directly into kinetic. So P times T is the energy, the total energy given. Great, that's the answer to the first part. That is the kinetic energy as a function of time, and hence its velocity as a function of time. Well, 2pt over m equals v, so v is equal to the root of 2pt over m. Got it. Hence, calculate the acceleration of the car. Well, we know that the acceleration of the car is dv dt. Again, that's not for your ESAT, but it could be for your interview. Sorry, calculate the acceleration of the car. And the distance is the integral of v dt. So I'm going to call that root 2p over m times t to the half. So the acceleration is that differentiated, which is a half times that thing to the minus a half. So I'm going to put that in there. So 2p over mt is acceleration. The displacement, raise that, becomes 3 over 2, 2/3. Root 2p over m t to the 3 over 2 plus c, although when t equals 0, s equals 0, so c would equal 0 as well. So that's the distance moved. Find the limiting value of the velocity at very large times. It would be infinite, and comment on whether that seems reasonable. No, because that's more than the speed of light. Find the limiting value of the acceleration. When t gets large, it tends to 0. Comment on whether that seems reasonable. Oh, very large times. So when t tends to infinity, a tends to 0. That does seem reasonable because there should be some sort of maximum speed it reaches. But when t tends to 0, a tends to infinity, that's the part that's not reasonable. Realistically, there would be a finite starting acceleration. Instead of driving the car forward, a motor could be used to lift the car up a vertical rope. Calculate the height which the car can reach as a function of time. So I tell you what, let's pause for the question. So you're saying, confused why you're so bad at ESAT? Maybe not true. On the ENGA tests, I can only make it to question 25 most of the time within the 60-minute limit, with many wrong too. What should you do? You do further math, physics, and DT. Okay, so it sounds like, first of all, you're going to want to really employ a multiple pass strategy and take one of the past papers that you've done, compare that to my live solve so you can see how I put that technique into practice. So you want to look at a question, immediately decide if it's doable quickly. If it is, you do it then and there. If not, you skip it, move on, right? So one of the biggest time wastes is looking at a question and insisting on doing every question as it comes. You want to first find all the very fast, doable questions and get them out the way. So that's one thing. Second thing you want to do is to work on your speed by doing speed runs of your GCSE paper or your AS papers or your Solomon papers so that you build up that muscle for how to work quickly. You can even use the ChatGPT stuff I did right at the start of this stream. Give yourself some short bursts to work on that speed muscle, and you'll slowly find yourself getting faster over time. It may be unfamiliarity with the style of an ESAT question. So they trap you a lot. Like, so you understand the syllabus well enough to get an A star, but have you mastered the syllabus? Have you picked up every little stone? Have you looked in every nook and cranny? Is there anything hiding? So even I get caught out sometimes in the live solves, which you can see from my videos from last year. I think technique is going to be most of it. And what you can do sort of as you mark them up, instead of, so your main takeaway from marking up should not be, oh my God, I did such a bad job. Your main takeaway should be, all right, okay, so that went wrong for this reason. And every mistake you make, you can improve your system. You can improve your process and think, if I see a question like this in future, what's the trick? What are they really testing for here? How does this work? So without seeing you specifically do a run, that's the kind of general stuff I would advise. But you're right that it's very, very fast, and that's why multiple choice exam technique is really the way to go. I would also do stuff like this. Really push your problem solving skills so that the ESAT stuff looks easier in comparison. Maybe if it's like math skills, you can go to like mixed exercises and just sprint them as much as possible. So your skills are like, oh, look at that, differentiate. That's fine. Making sure you make no execution errors. So maybe you conceptually understand what you're supposed to do, but maybe you make small mistakes here and there with your math. So yeah, that kind of thing. Really analyze why you're losing mistakes. Is it because you don't understand the question, or is it because something's going wrong on the way? Or is it because of your exam technique that you need to do some work on? So there's plenty of stuff to analyze about your performance, and then kind of work from there. If you have anything specific, obviously keep dropping it in the chat and I'll keep responding. Just checking a quick. Yeah, okay. So let's go back to this question E. Not the entire screen. That's the one. Okay, so what's happening here? We have our battery supplying a constant power of P, and this time that is going into the GPE. So the height would be PT over mg. Hence calculate the velocity at which it climbs the rope. The velocity is the differential of that, which would be the constant P over mg. The calculation in part E ignored the fact that as the car is moving, then some of the power must have gone into the initial kinetic energy. Assuming that the approach you used was correct, calculate the ratio between the kinetic energy. Well, the kinetic energy would be a half mv squared, which is p squared all over 2mg squared. Calculate the ratio between that kinetic energy and the potential energy, which is PT. So the kinetic energy all over the potential energy is P squared over 2mg squared divided by PT. So it's P over 2mg squared T. Use your result to determine under what circumstances it is reasonable to ignore kinetic energy. So it's reasonable to ignore kinetic energy in this way when this ratio tends to 0, and that happens when t tends to infinity, in other words, for large times. And that's the physics. Sorry, one more thing. So one thing you can do, if you look again at my live solves for a paper that you've done in the past, look at the way I'm analyzing myself look how much sort of post-game work I put in, looking at every single question, looking at my splits, thinking, could that have been done a better way? Like, there's so much you can gain from the sort of post-game analysis of a run, which I really recommend you do as well. Make sure there's no information left on the table when you analyze. All right, so getting into this now, that was section 1. Let's do section 2, which is the mathematics for physics. No calculators may be used in this part, which is great. And let's just get into it. Evaluate this thing precisely. No problem. That is a difference of 2 squares. So that's going to be 2007 minus 2006 into 2007 plus 2006. Well, that's just equal to 1. So the answer is 4013. Good. Evaluate this to 1 sig fig. Well, that's 1.001 to the 5 into 1.001 minus 1. So in other words, it's 0.001. Ooh, sorry, off topic. This is worth interrupting because I've been looking for these papers that also discontinued that are relevant for ESAT. Sorry, bit off topic, but what are ECAA papers? And are they relevant for ESAT? I'm going to have a look at that right after this because I lost them. So thank you if this is correct. So I'm going to hold on to that until I'm done with the math because otherwise I'll just get very tempted. Actually, I'm going to have a quick look now. So the ECAA past paper, you don't have to threaten me with a good time. Give me a new past paper. I'm sold. So that was the economics admissions test. My understanding is that's more similar to the TMUA, which is still used for places like Imperial and Oxford for their economics degrees. So I would expect it to be a little bit more pure math and more in the TMUA style of logic and proof. Although some of this is so, I hate that. I hate that so much. Okay, so section 1 doesn't seem very relevant for ESAT. The advanced math is extremely relevant to the ESAT. Sorry, I got waylaid. We're doing this. We're here now. While I'm here, let me show you what I'm seeing. So rather than just sort of reacting with you not being able to see. So let's look at this section 1 over here. So what I'm looking at, it starts off with, so this is the ECAA, which was for economics. I think this has also been discontinued, and been replaced with the TMUA maybe. So it starts off with problem solving, which is bad, but the advanced math is good. So the problem solving, I mean, maybe stuff like, but it's just a bit not very ESAT-y, like at all, like in the slightest. Hate, loathe, detest, no, make it go away. I don't want to see it. But the actual math in this section 2, this part B, advanced mathematics, this I'm looking at, that is so ESAT. This is so ESAT. Yeah, problem solving is really good for TAR prep, quite right there. This math, very good for ESAT. I do believe there are some, though, that get weird. Yeah, so statements like this feels more TMUA. So as you get to the more challenging bit, and you start to see things like sufficient. So as you get to the end, the questions start to get a bit more TMUA and a bit less ESAT. But if you do enough of the NSAA papers or the ENGA papers, you'll get used to like the style of an ESAT question. And so if it's asking you for like necessary and sufficient, that's just not it. So you can make use of that. Let me see about if the section 2 is any good. So section 2, oh no, that's long form. Section 2 you ignore. Let me confirm that was still true after 2020. Yeah, so we ignore section 2. So if you are planning on using the ECAA, in fact, I'll probably do a run of this. This looks quite fun. The ECAA, stick to just Part B Advanced Mathematics, which can help you with your Math 2 skills. Problems. So there's only one paper per year for this, right? Correct. And I would still only be using the part B for that. Right, let me keep going with this PAT test math stuff because I'll explain. In fact, I'm willing to change it up on the spot. Let's do the ECAA and maybe a bit of the math. Like I'm just sort of I think my 3 p.m. canceled. I've got some time, guys. So I just want to run through it. Let's have some fun. Let me just lay down a bunch of stuff to make sure it's out there. So this thing here, so 1.001 to the 5 times the 0.001. So that's 1 plus 0.001 to the 5. Now let's binomially expand that. So 0.001 into first plus 5 lots of 0.001 plus a bunch of other stuff, which is 0.001 to 1 sig fig. Got it. Okay, so find the gradient of the line joining these 2 points, not a problem. Gradient is change in y all over change in x. The change in y goes from there to there is minus 10. When it goes across 1, it is minus 10. Find all the values of what x for which this thing, oh man, they even called it log to base e. So that just means that 3x is equal to 6, which means x is equal to 2. And then here, that means 3 to the 2 is 9. So x squared is equal to 9, and x is equal to plus minus 3, which still works because that is a positive argument. That's fine. This guy, we're going to go across. We're going to find a nice 5, 12, 13 triangle. Pythagorean triples, get to know them. So the simple ones, the 3, 4, 5, obviously, 5, 12, 13. I think there's one with 7, 24, 25. Let me check. Yes, 7, 24, 25. So your Pythagorean triples, good to go. So that's theta. So inverse tan of 12 over 5 is theta. Sine of theta is opposite over adjacent is 12 over 13. Multiplied by 13, the answer is 12. So in other words, just draw a representative triangle in which this thing would be true, and then you get there. So sketch the following functions. So sine squared, what's going to happen is, now I'm going to cheat because I know the answer. It does something like this. The way you can get there is you can draw sine. Wherever sine was negative, now becomes positive. But also this differentiates smoothly. So if we differentiate that, we're going to get 2 sine x cos x. So we can see here at pi, where it was initially 0, the gradient is 0. So instead of it being a sort of sharp modulus looking graph, it's a nice smooth continuous curve. Or alternatively, you can get there from the double angle formula if you've gotten that far in your math syllabus. Do you know about any unofficial ESAT 2024 and 2025 questions? No, sir, I do not. And that's one of the things that really bothers me about how they're doing it now is the fact that they're never releasing a past paper again, which I just think is deeply unhelpful, especially because a lot of students report that the new ESAT, like we've done in the actual room, is harder than the practice material. I find it unhelpful, but no, I don't know of any. Certainly not anything official. And I'm kind of skeptical of like, oh, I saw this. So no, unfortunately. If you guys find one, feel free to bring it into like sort of here or the Discord. I'm happy to spread that. But no. So back to the paper real quick. Alternatively, for sine squared of x, we can say that cos 2x is equal to 1 minus 2 sine squared x. So sine squared of x is equal to 1/2 minus 1/2 cos 2x. So when x equals 0, it's equal to 0. And it's raised by 1/2. It goes between 1 and 0. So this 1/2 raises the midline to 1/2. This 1/2 changes the amplitude to 1/2, which means it goes between 0 and 1. And the cos 2x affects the periodicity. So that is sine squared x. Now this guy, that is 1 over x plus 1 into x minus 1. These are on the bottom, so these are going to be vertical asymptotes at 1 and minus 1. we can see when x is equal to 0, it's going to be equal to -1, and so it's going to do something like this. So when x tends to infinity, it drowns out and goes to 0 from above. When x goes to -infinity, it's going to drown out the -1 and go to 0 from above. And then in between, it's going to be discontinuous and go through the point 0, -1. Oh, apparently. Oh, so you're saying there are reputable ones for TMUA, but you haven't seen one for ESAT. In fact, if you can send me the reputable TMUA one, I currently don't know about it, and that would be super helpful. So for here, circle A has radius, which is 1 centimeter bigger than circle B. So B. So area of B is pi r squared. Area of A is pi times r squared. So it is pi into r squared plus 2r plus 1. So it's pi r squared plus 2 pi r plus pi, which is the area of B plus 2 pi r plus pi. So that thing is 2 pi. So 2 pi r plus pi equals 2 pi. Pi's cancel, makes that 1. So 2r equals 1, r equals a half. And that means that RA is equal to 3 over 2. For 7, we have 3 dice thrown, one after the other. All 3 dice give a 6. That's 1 over 6 cubed, which is 1 over 216. All 3 dice give the same number. Well, it's that times 6, which is 1 over 36. So you add on, so that's the same for it being one specific number 3 times in a row. And there's 6 options for that. So we add 6 of those together. Only the third die gives a 6. Well, that's 1 out of 6. That means you only care about the last one. Oh, no, I lie. That's just the probability that the third die gives a 6. That's not the probability that only the third die gives a 6. So first you have to have a not 6, then you have a not 6, and then you have a 6. So it's 25 over 216. For 8, volume of a spherical increases by 1 centimeter cubed every second. So dv dt is equal to 1. What is the rate of growth of the radius? Well, we know the volume is 4/3 pi r cubed. So dv dr is 4 pi r squared. We know that dv dt is dv dr dt. So dv dt, which is 1, equals dv dr, which is 4 pi squared dr dt. So dr dt. Now, if you're struggling with this, this is connected rates of change in the differentiation chapter of the AS book. Now, we're told that the surface area is 100, but surface area is 4 pi r squared. So this thing on the bottom is 100. So it is 0.01 centimeters per second. Nope. Yeah, well, that's the answer. Now this looks fun. Find the area between the curve y equals the modulus of x to the n, where n is a positive constant. The line defined by y equals -2. And the lines defined by that. Okay, let me kind of sketch out what's happening here. Y equals -2 is here. The modulus of x means that x is equal to 2 or -2. So this thing. Okay. So what do we know? So so that's your y, that's your x. This is x equals 2, this is x equals minus 2, this is y equals minus 2. Okay. Let's sort out what's happening here. So modulus, when it's 1, it's just simple v. When it's 2, it is its simple quadratic. When it's 3, it's a cubic with that flipped. So they kind of just keep looking the same here beyond that point. So that's good to know. So what's going to happen is it's going to find the area between the curve. Okay, so what it's going to be is this rectangle, which is 4 by 2. So this has an area of 8, and then it's just going to be the integral of this thing. So when n is even, the modulus is just itself. So when n is even, the area so it becomes we get the integral from minus 2 to 2. Oh, no, this matters though, because of the symmetry, right? So when it's even, so that integral would be twice the integral from 0 to 2 of x to the n. But it's going to be the same thing, because even when n is odd, when you take the modulus of it, it's going to be symmetric about the y-axis. So regardless, the area is going to be twice this thing. So it's going to be twice the integral from 0 to 2 of x to the n. So it's going to be x to the n plus 1 over n plus 1. Twice that between 0 and 2. So it's 2 into 2 to the n plus 1 all over n plus 1. And then you plug in 0, you get nothing. So that's 2 into the n plus 2 over n plus 1. And then the total area is that plus 8. I like that. That was fun. Sum the following. So here, this is a geometric series where a is equal to 1, and the common ratio is e to the y. And ey is much less than 1, so it converges. We're summing to infinity, so it'll be a over 1 minus r. This one. Well, this if we're adding the logs, we can multiply the arguments. That's log 2 into 1 times 2 times 4 times 2 to the n. So that's log 2 into 2 to the 0 times 2 to the 1 times 2 to the 2 times 2 to the n. Well, that's log 2 of 2 to the sum of those guys. Now the sum of those, so that's going to be 2 to the, now that's going to be n plus 1 over 2. But the point is the log 2 and the 2 cancel, so it's just n plus 1 over 2. And I got the n plus 1 over 2 because that's the sum of the first n natural numbers. So in other words, we could treat that as an arithmetic series with the first term being 1 and a common difference being 1, and the sum of n plus 1 terms is n plus 1 over 2 into 2a plus n minus 1d. Oh, I did get that wrong because it doesn't start on 1. It starts on, but no, but that's the same. So the powers, no, I said a is 1. Sorry, this would have worked if a is 0. So n plus 1 if a is 0, or it's n terms if a is 1. 2a plus n minus 1d. So there, n plus 1 over 2. Cool. Identify and classify the stationary points of this function. Nice and simple. Not a problem. Will equal 0. So let's divide by minus 6 and get x squared. Divide that by minus 6, we get plus 3x. Divide that by minus 6, we get minus 4. So we get x plus 4, x minus 1 equals 0. So x is equal to minus 4, or x is equal to 1. When that is true, y is equal to, oh no, don't make me do it. All right, so 5 minus 96. What is 9 times 16? 144. By the way, how I did that was I said that's 3 squared times 4 squared. So that's the square of 12, 144. Now this is going to turn that into a plus. That is 2 times 64 is 128. I'm going to turn that into minus 100 and minus 140. So taking a plus 4 on that, minus 4 on that. Cool, that makes it a lot nicer. So that's minus 240 plus 128 plus 5. So minus 240 plus 133. So minus 240 plus 140 minus 7 minus 107. I really did not enjoy that. X on this one, when x is equal to 1, it's just very simply, it's 5 plus 24 minus 9 minus 2. So it's 29 minus 9 minus 2. 20 minus 2 is 18. So we found our two stationary points. Let's classify them. Let's take the second derivative, which is minus 18 minus 12x. When x is equal to 1, the second derivative is minus 30, which is less than 0. Therefore, the gradients are decreasing around that point, and it's a maximum point. When x is equal to minus 4, the second derivative is going to be equal to minus 18 plus 48 is going to be equal to 30, which is bigger than 0. So the gradients are getting bigger, and it's a minimum. And finally, here in the figure below, the radius of the larger circle is twice that of the smaller circle. Find an expression for the fraction of the area that is occupied. Okay, whenever you have a problem involving circles, draw on any relevant radius always. And then the line connecting the two centers will go through this point of intersection. So if the radius of the larger circle is twice that of the smaller circle, then we're going to have R, 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 2R, 2R, 2R. What we're going to be able to do is to join that up and get the full length there. So that's going to be 2R, 2R. This is going to be 2 root 2R. And that's going to be R, R, which makes this root 2 times R. And so if the total thing is L, then root 2L, which would be the diagonal of the square, is 2 root 2R plus 3R plus root 2R. So it's 3 root 2R plus 3R. So the length is that thing divided by root 2, which is 3R plus 3R over root 2, which is 3R plus 3 root 2 over 2R. So that's the length. So the area of the square is 3R into 1 plus, well, in fact, I'll keep that as 3 over root 2, and I'm going to square that. I'm going to square that as well. So that's from factorizing a 3R out. And let's square this out. So you get 9R squared into square the first, square the last, and twice the middle 2. So 9R squared into 1 plus 9 over 2 plus 6 root 2 over 2 is 3 root 2. That's 11 over 2. I don't like that. But then it's, so that is pi times r squared is 4 pi. So it's 4 pi r squared plus pi r squared. So the total occupied is 5 pi r squared, clearly. So we're going to have 5 pi r squared is the area occupied over the total area, which is 9r squared into 1 plus 9 over 2 plus 3 root 2. Cancels, cancels. Have I done something wrong here? I'll tell you what I could have done. Oh, I'm not sure it would have helped. That divided by root 2. That's 3r. 3 over root 2. So take a 3r out. Oh, I should have taken... No, okay, I did do something wrong. I should have taken that out. That should have been a 1 over root 2. I apologize. Sorry, team. That felt wrong. See, I like... It's good to have a sense check. It's 1 plus a half plus 2 over root 2. There we go. So that's 9 over... So it's that into 3 over 2 plus root 2. Still doesn't feel great, but it's fine. So what we're going to do now is rationalize the denominator and hope that works. In fact, I'm going to multiply top and bottom by 2 first. So 10 pi over 9 into 3 plus 2 root 2. I'm then going to multiply top and bottom. So 10 pi over 9 into 3 plus 2 root 2. Multiply top and bottom by 3 minus 2 root 2. So we get 30 pi minus 20 root 2. No, I should keep the pi factorized out. So it's 10 pi into 3 minus 2 root 2 all over 9 into 9 minus 8, which is 1. So that does come out quite nice, actually. All right, that's my answer. What I'm going to do now, I'm going to check that I didn't do anything silly, because I want you to have correct information. So C was correct, A is correct, A is correct, C, good, is correct, B is correct, D is correct, C is correct, C for 8 is, yep, then B, then C, good. Dimmer, normal, normal, off. Dimmer, normal, brighter, normal, good. 1178 is correct. For this one, rocket started slowing down. Ugh, come on now, do better than that. This is it falling. It's free falling. The engines are turned off and it's free falling. Only it isn't, because it's still moving up, so it's decelerating. But now it just becomes a normal projectile. Just before X, fuel is used up, so the mass decreases. Good, good, good. Describe the subsequent motion. Yeah, decelerates uniformly until it hits the ground, and it's the area under the graph. Yeah, cool. This velocity was correct. Yeah, I could have simplified the numbers a bit there, but that's the same thing. That's correct for the distance. For other times, yeah, you can't have infinite speed. You can't have infinite acceleration. This is all fine. Yeah, this is all fine. So let me look at the math real quick. So 4013, yep. 10, yep, that's correct. Minus 10, 2 plus minus 3, 12. Looks like that. Looks like that. Good. Half and 3 over 2. Good. Yep, those probabilities are correct. 0.01 centimeters per second is correct. I really enjoyed this, which turned out to be correct. 9 was fun. 10. Yes. Yes. 4 minus 107 is a minimum point, and 118, good, is a maximum point. Good, I got that. And this guy here, they didn't rationalize, and that's silly. So I'm going to say I got that right. So yes, all this stuff in here is good. So that's how to make use of a PAT test. You can judge for yourself how reasonable you think it is for your ESAT strategy. Now what I'm going to do is I am going to hop across into the ECAA that I see here. So I'm going to download the section 1. The past papers. So the ECAA section 1 is good for, was very good if you're doing TMUA prep. If you're doing ESAT prep, it's good for Math 2 up to a limit. So if I stop sharing that and start sharing this, let me get that up for you guys. Okay, so let me show you how this can work. So you're going to ignore the problem solving. We're going to skip to part B, which is going to feel very ESAT. Just for fun, I'm going to time myself. I want to see what my splits are, because I want to see if they're comparable to ESAT splits, which should be 90 seconds a question without extra time. So this is going to be very rushed, but then I promise I'll go back and explain my reasoning a bit better when I'm marking, or if I feel like I need to. So I'm going to start the clock now. So first 3 terms of a geometric series. So that's AR squared are equal to the first, 5th, and 6th terms of an arithmetic. So 4D is equal to AR minus R and 6th term. So we also know that D is equal to AR squared minus AR, and we know that 5D is equal to AR squared minus A. Cool. Given that the terms in the geometric series are all different, find R. So we got to find R. So 4AR squared minus 4AR is 4D, and that's equal to AR minus A. 4R squared minus 4R equals R minus 1. 4R squared minus 5R plus 1 equals 0. 4R and R and minus 1 equals 0. So R is a quarter, or R equals 1. If R equals 1, then they are all the same, so it's not that one. R is a quarter. Common ratio is a quarter, which is D. Good. Split time. One of the roots of this equation is, where k is a constant, is 4 more than the other root. Well, we know that x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. So the difference in the roots, so they're going to be centered on minus 9 over 4, and we're going to have the plus square root over 4 and the minus square root over 4. So twice that. The difference between them is root 81 plus 8k over 2 is the difference between the roots, which is equal to 4. So root of 81 plus 8k is equal to 8. 81 plus 8k is equal to 64. 8k is equal to so knock 1 off both sides. Minus 17. Minus 17 over 8 is k. Split. Diagram shows the cross-section of a cylindrical kitchen roll. Roll consists of 64 towels, each of which is a square of side that, and they are tightly wrapped around in it. I'm so confused. Pass, skip. You see, multiple pass strategy. I'm not getting this quickly, so I move on. I'll come back to it later. Each of the real positive numbers is increased by 20%. What is the resulting percentage increase of that? So it's going to go to 1.2 cubed ABC all over 1.2 times 2D plus 3 times 1.2 cubed BCD all over 1.2 into a plus b plus c. So in other words, it's 1.2 cubed over 1.2 into this entire thing. So it will be increased by 1.2 squared, which is 1.44. So it's a 44% increase, which is C. Done. Do you see how that's first pass? I was moving through that without resistance. So a sector of circle of radius x contains an angle. Perimeter of the sector is going to be x plus x theta equals 12. Okay, so what's the maximum as x varies? So we want to rearrange this for theta. So x theta is equal to 12 minus 2x, and theta is 12 minus 2x all over x. The area of the sector is a half x squared theta, which is a half x squared into 12 minus 2x over x. Cancels equals 6x minus x squared. And then dA dx is going to be equal to 6 minus 2x, which will equal 0 when x is equal to 3. So the maximum possible value of the area of the sectors is when I plug in x equals 3 into here, which will be, I could have just completed the square. So it's 18 minus 9 is 9, which is C. Done. So there's a partial sketch of this curve. The curve cuts the x-axis at only one point and does not touch the x-axis at any other point. The y-coordinates are both positive. Find the complete range of values to p. Okay, so this is based on, so you work out the number of roots of a cubic by finding the turning points. So we're going to differentiate and get 6x squared minus 18x and 12. We're going to set that to 0. We're going to divide by 6. And so it's going to be x minus, Ah, 12 divided by 6 is in fact 2, guys. Educational content at its finest. So we have x minus 1, x minus 2. So x is equal to 1 or x is equal to 2. What we need, guys, is for this point to be above the y, above the x-axis when x is equal to 2. So when x is equal to 2, y is equal to, that's 8, that makes that 16. So 4 times 9 is 36. Plus 24 plus p, and we need that thing to be bigger than 0. So we need p to be bigger than 36 minus 16 minus 24. So we need p to be bigger than minus 4. Boom. Split time. 29. Find all positive values of x for which this thing is true. Cool. No problem. Log 5 of x squared minus log 5 24 plus 10x is equal to minus 2. Moving that across. So that means that log 5 of x squared all over 24 plus 10x is equal to minus 2. And that means that x squared over 24 plus 10x is 5 to the minus 2 is 1 over 25. So that means that 25x squared equals 10x plus 24. 25x squared minus 10x minus 24 is 0. I can't be bothered to can I factorize that? Let's just go for the equation. So x is equal to minus b plus or minus square root of b squared minus 4 times a is minus 100, so plus 2400 all over 50. So it's 10 plus or minus 50 all over 50. So it's 1 plus or minus 5 all over 5. So it's minus 4/5 and it's 6/5. So 6/5 is the only positive value. Got it. Okay, split. So this is feeling very ESAT, guys. Saturday, Jez visited his friend in a neighboring town. He cycled the first 5 kilometers at an average speed of that. So how long? 10 kilometers an hour. So he took half an hour then. He took 30 minutes. And then immediately caught a bus which traveled the remaining 10 at an average of 30 kilometers per hour. So he made it a third of that. So that took 20 minutes. So the average speed is the total distance all over the total time, which was 5/6 of an hour. So it's 6/5 times 15. Cancels down to make it 3. It's 18 kilometers per hour is B. Next. Find the total area enclosed between that, the x-axis, and the lines that. So we got to integrate x cubed minus ax squared minus 2a squared x. And we're doing that between minus a and a. So it's a quarter x to the 4 minus a over 3x cubed minus a squared x squared between a and minus a. So it's going to be a to the 4 all over 4 minus a to the 4 all over 3 minus a to the 4. I'm going to subtract from that a to the 4 all over 4 plus a to the 4 all over 3 minus a to the 4. That's going to cancel. That's going to cancel. That is minus. Should that be negative? I suppose it could be. Oh, no. Wait. Guys, I did it wrong. Guys, I just did it entirely wrong. All right, what I should have done, I should not have taken that. I should have sketched it, guys, because then I would have seen that some of it is negative and some of it is positive. And so I've done it just dead wrong. So apologies, this split time is going to take me way too long because I'm already 1.5 minutes in, which is my time allotted. But if I'd sketched that, bother, it would have gone through minus a, 0, and 2. So what I actually have to do is to integrate it between. So I have to integrate. So it is x cubed minus ax squared minus 2a squared x to be integrated. When I integrate that, it is a quarter x4 minus a over 3x cubed minus a squared x squared. But the point is I have to do it first between minus a and 0, which is going to give me the positive one. So it's 0 minus a to the 4 over 4 plus a to the 4 over 3 minus a to the 4. So that is 7. So it's a to the 4 minus 7/12 of a to the 4, which is 5/12 of a to the 4. That's that area. And the other one is going to be the same thing between 0 and 2a. When I plug in the 2a, so no, not is where is but a actually. Apologies. It will be a to the 4 over 4 because it's specifically telling me to do that. When I plug in a, I'll get a to the 4 over 4 minus a to the 4 over 3 minus a to the 4 minus 0, which is 3a to the 4 minus 4a to the 4 minus 12a to the 4 over 12. So minus 16, so that's minus 13 over 12a to the 4. But that actual area is 13, so to add that all together, it's 18 over 12a to the 4, which is 3 over 2a to the 4 is the total area, which is D. Apologies to this question. I'm sorry. So a curve and a line. What's the shortest distance parallel to the y-axis between the curve and the line? Well, let's draw this out. So that looks something like this, where it goes through 2. When x equals 0, y equals minus 6. What is the shortest distance parallel to the y-axis between the curve and the line? So the shortest parallel to the y-axis, that means what is the smallest value of the difference? So the difference between them is 3x squared minus 5x plus 8. We want to minimize that distance. Let's complete the square, actually. So 3 into x squared minus 5 over 3x plus the 8. 3 into x minus 5/6 all squared minus 25 over 36 plus 8. So that's 3 into x minus 5 over 6 squared. I have seen that you have dropped a thing in the chat, but with permission, I'm going to wait until I've done this because I'm in the flow and I'm timing it. 6 squared minus 25 over 12 plus 96 over 12. So that will be the minimum distance. So 96 minus that. So that's going to be 71 over 12, which is D. Next. Bag contains only these. These balls are identical apart from color. One is selected at random and not replaced. A second ball is then randomly selected. What is the probability that at least one is red? That's 1 minus the probability that none are red, which would be 2n over the 3n initially. Minus, and then there's 2n minus 1 lots of blue balls left, and then 3n minus 1 total from there. So that's 1 minus 2/3, which is a third, minus 2n minus 1 over 3n minus 1. So that's going to be 3n minus 1 minus 3 lots of 2n minus 1 all over 3 lots of 3n minus 1. So it's 3n minus 1 minus 6n plus 3 all over 3 into 3n minus 1, looking at the form of the bottoms there. So it's minus 3n plus 2. So 2 minus 3n. No. Okay, what did I get wrong? So 3, oh, that's correct. All the balls are identical carbon, but only contains that. So the total is 3n at the start, 2n of which are blue. What is the probability that at least one of the selected balls is red? Well, that's 1 minus the probability that none are red, so both are blue. There's a 2/3 chance that the first is blue. Oh, bollocks. That should have been multiplied. All right. So it's 1 minus that. So it has to be that one and that one. So 2/3 of that. Okay. I should not be making these conceptual mistakes, guys. I apologize. But this is why you practice. You make mistakes at speed that you wouldn't make slowly. And it's been a while since I've done one of these. So 4n minus 2 all over 3 into 3n minus 1. 1 minus that. So it's 9n minus 3 minus 4n plus 2 all over that thing is 5n minus 1 all over that thing, which is E. Cool. We start to get into the necessary and sufficient. So I'm going to, for the interest of timing in terms of, so I'm going to try and understand what this one is, because this is the last one that feels very ESAT. And they're tightly wrapped around an inner cardboard tube with diameter 5. So that is 5. The outer diameter of the roll is 11. And the length of the cylinder is 25 centimeters. Yes, it is. The thickness of an individual talon minimum is estimated from this information. Which of these estimates is the best? Oh, man. Why don't I do it? Okay, so what we know is that if I'm looking at the side of a thing, it's going to have 250 millimeters of length. So I'm going to multiply that by the thickness, and that's going to be the area I look at. So let's work out the area of this. So this is going to be pi r squared minus pi r squared is the total area. And I need to divide that area by 64. And that will be the thickness of one towel, which is 250 T. So the thickness is given by pi into 5.5 squared minus 2.5 squared all over 64 times 250. Right, well, the 64 times 250, let's take a 4 from that and put it